YouTube lovers, welcome to my channel. I'm Sebastian. Today I'm going to show you how to control an LED using this, an ultrasonic sensor module. It's called the HC-SRO4. And to power the HC-SRO4, I am going to use a Raspberry Pi 2 Model B. So, you will need the ultrasonic sensor in the computer, the LED colour, you could use white, green, yellow, whatever you feel. I'm going to use red. 3 male-to-male jumper cables and 6 male-to-female jumper cables. A 220 ohm resistor and a 1k ohm resistor. How do I tell the difference? If you look closely, one is darker and one is lighter. That's how I tell the difference. And to fit all these things in, I'll be using one of these lovely solderless breadboards. It's easy to use, you don't need to do any soldering, as it suggests from the name. So, to get started, you'll need to do the electronics first. Else, there's a good chance that the Raspberry Pi might blow up. So, to get started, we'll set up the HC-SRO4. So, basically, implant the ultrasonic sensor into should show you this going in first. And so implant it in the A section at the front. So then you'll need, this is where your male-to-males come in. So put a male-to-male in here, and a male-to-male in here, and a male-to-male in here. Now, the pins on the ultrasonic sensor mean things. Now, if you look on the front, you should see some letters here. This is the power, the VCC. The trig is the output. That basically sends the sound beam from here all the way to the object. Echo is the input, which detects what's the trig set, and it goes into the ultrasonic sensor to be processed. And the ground is the ground to stop it the electric current. When you touch it, it just making you explode with electric shock. So that's the not so interesting bit of electronics of the ultrasonic sensor. Right, let's now put these into F. Careful not to put them into a different place. Hey, what have I done? I haven't even put that in the ground section. So, that is the male-to-male setup. Resistor. Now the resistor is basically for changing the electric current, so it doesn't, because the ultrasonic sensor doesn't have a fuse. But that's where this comes in. It basically slows down the electric current, so it doesn't just go kaboom in your face. So what we'll do is connect it to E and F. And you know that it's connected to the ultrasonic sensor, because on a breadboard the letter sides go down, the electric current goes down on each side. That's why we've got the male to males. That basically, if you had the female to males stuck in here, it wouldn't connect because there's a gap for the on the electric current. That means it would not work. Boo hoo, boo hoo. But never fear, because we've always got male to males. Make sure it's easier to use smaller ones like these ones, so you don't have to go through like 3 meters of male to male when you're trying to get through little tiny pea size compared to Mount Everest wires here. So make sure these are the peas and these are the Mount Everests. Well, these always are Mount Everests. So the resistor goes in here. Make sure it's the 1K. The 1K is the lighter coloured resistor. So next, get the Raspberry Pi. And to connect it, you don't connect it to the surface or any of these. You connect it to these pins here. These are called the GPIO pins, and they're used for engineering and electronics. And that's what we're going to be using. So, what we're going to do is put them into, I'm going to explain it in the physical locations, because you can have BCM and board settings. I'm going to use the board setting. So, first I'm going to put the VCC cable in. Now, it should be connected to a 2 volt power, which I'm going to use number 1, 2. Is that VCC? Hooray! We've got that. Alright, the trig, just make sure, yep, that's trig. I'm going to use yellow, and I'm going to connect it to pin 12. 1, 2, 4, 6, 8, 10, 12. And then I'm going to connect the echo to pin 7. 1, 3, 5, 7. And the ground to 6. Also known as a ground pin. How did I know that? Because it's the most simple thing in the world. Except for 2 plus 2. So, put that in there. Do a quick pin check. Just to check if all the pins are in the correct places. VCC. Trig. 1, 3, 4, 2, 4, 6, 8, 10, 12. Echo. 1, 3, 5, 7. Ground 6. Hooray! Now, LED. So, basically, implant your LED into A. And get your 220 ohm, which is the darker colour. Now you should see on the LED there's a long leg and a short leg. Connect the resistor to the short leg. And so make that go over the gap. There you go. Then I'm going to make that orange and connect the long leg there. You don't need a resistor for that. So for the orange, I'm going to connect that to a 3.3 volt and the purple to pin 11. So 1, 3, 5, 7, 9, 11. pin check. Is that in? That in? Blah blah. Is that in? So is in. That is the ultimate pin check. Then, right, let's set up the Pi. So to set up the Pi, this will be difficult. You have to turn it around. Now, you can see there is a metal slot here. That is where the micro SD card goes in. So just slot it in there with the colourful parts face up. Then connect it to a keyboard and mouse. So that's the first part done. Now, just connect it to the monitor using this slot here and the HC-MIDI. And then you'll have to video the monitor for this bit. It's the special bit. And so then basically put that into the mains. The micro USB cable into the Pi. Then just wait. Hooray! We've got some colours! That means, hooray, you've got it on. You've succeeded. Then, something strange will happen. Whoa! Yes, I hear you cry. Is something going wrong? Is there a bug on it? Is it doing a scan? No, it's just starting up. It's usual Raspberry Pi. Then, log in with username Pi and password Raspberry. Then, to get to the desktop, put Start X in where it says Pi at Raspberry Pi. Hooray! Then, these won't all be on here because I've been using it since we got the Raspberry Pi, but this is the desktop. So we've done the electronics, programming. So for this project I'm going to be using the programming language called Python. So open up the terminal and create a new file called Sensor Ultra, or you could put just, I'm going to call it Ultrasensor.py. Then we're going to open it in Nano, a code editor. So put sudo nano ultra sensor.py. Just check out, I've got 2 spaces there. Else it will go absolutely ballistic and say that is wrong. Right. So that's when you put sudo nano ultra sensor.py, or whatever you've called the file. So that is the screen of Nano. So for the basic imports, this bit is optional for the red part up here. So can you see the code? See the code in Metro HD. Okay. So that is the first line of code you will put. Then import rpi.gpio as GPIO. rpi.gpio should come with the Raspberry Pi and Raspbian. But if it doesn't, you can always go to the Python or the rpi.gpio website and download it from there. Then import, well, don't do it in capitals, else it will go mad and it will say, no, that is wrong. it should change colours. That's when you got it right. So import time. I have got it right even though they're grey. It's just because it doesn't, because you're importing things, it doesn't, they're not built into Python. They're different libraries that you install. So you put the import RPi as GPIO as import time. So now we'll begin to set up our Python. So we're going to do now the fourth line of coding. GPIO dot set mode GPIO dot board. I believe you remember me mentioning earlier about BCM and board. Now the GPIO board sets it to the physical locations of the GPIO pins. It's now time for the fifth line of code. This is getting really, really exciting. Ish. So that basically stops it from complaining about this file is running already. Shut it. Basically that stops it from saying that. And then it mentions about actually doing that to stop me bugging you with information about stop it. Right. Now GPIO dot setup. Now we have to go back to the electronics now, and we have put the trig, if I remember rightly, into place 12. So on the setup we put 12 GPIO dot out. As I mentioned to you with the electronics as well, the trig was the output. It develops the sound and it goes to the actual object. And then GPIO dot setup 7, not 78, I haven't got 78 pins, so 7 GPIO dot in. That is marking the echo. GPIO dot setup 11 GPIO dot out. And the 11 is the actual input pin location for the LED. At least we finished the setup now. So GPIO dot output 12 false. Or you can put true. I think it's false. Yes, false. Then you go while true. That basically means repeat until Control C is pressed. Well, that's if it's except keyboard interrupt. You don't need to put that because the terminal picks up what keyboard interrupt is. Or shall I say rightly, Python picks up what Control C is. So, while true, GPIO dot output, and we're going to put 12 true. Or actually you need to configure the ultrasonic sensor first, else it won't pick it up because it will be such in a rush it might explode. So what you have to do is time.sleep. for 0.5 seconds. The time.sleep always is seconds. Don't need to worry about that. Then put in where it's actually sending the beam. Then time.sleep. But this time for 0.00001 seconds. GPIO dot output 12 false. Now I'm going to do while GPIO dot input 7 equals 0. Start equals time.time. Then we go while GPIO dot input 7 equals 1. Stop equals time.time. So there we've created 2 new variables. So then we're going to do some mathematical calculations. And don't worry, you don't need to do import math. So what we're going to now do is create our 3rd variable. So beam equals start minus stop. Sound equals 34000 divided by 2. And then distance equals beam multiplied by sound. But we're not going to print the distance. Well, first we have to, we don't need to do that actually. And so distance is now finished. But now we have to make the LED work. So if distance is greater than or equal to 3, then we'll put GPIO dot output 11 false. For some reason, the LED works opposite to the ultrasonic sensor. And then we're going to put elif distance is, oh, actually there's something wrong up here. It's not actually greater than, it's less than. If distance is greater than 3, GPIO dot output 11 true. GPIO dot cleanup. Then we put Control O and press enter. Control X. Sudo Python ultrasensor.py. Hooray! This has now worked. Now I'll just quickly get an object to measure distance with and see if this works. I've noticed that I have made a bug in the coding. So what you have to do is stop minus start. I made a silly mistake by doing start minus stop. And also you need to put round distance 0 so it doesn't go completely crazy actually and not show the LED. So come up, Control O, Control X, sudo Python ultrasensor So let's see if it works. So I have to give it a chance to configure. Hooray! It's sort of like an alarm system. Intruder bot. So, the summary is, we have managed to. Oh, I better turn the program off. So to turn the program off, just press Control C, and to turn the whole Pi off, go sudo halt. Bye. And now, so we have managed to control an HC-SRO4 using Python and use it to control an LED. So, wow. So, thanks for watching.